A quick reminder, this is a SEFIC event, and all events that are hosted by SEFIC are held in strict compliance with antitrust, as well as SEFIC do's and don'ts, which primarily ask that we refrain from discussions related to competition and compliance. So no pricing or production volumes. Please refrain from asking the speakers questions related to this because they will not be able to answer. And we will continue on to our next slide. So yeah, just a few pointers. Please mute your microphones. I have muted all microphones, but if you do turn it on, please keep it muted. It's very helpful for the entire presentation and the entire ambience for everyone if we all stay muted when we're not speaking. Um, I would like to also invite all of you to turn off your cameras, not because we don't want to see you. We would love to see you. However, we have all been over the past year dealing with online events. And if you have more than 100 people all with the cameras on, a lot of servers have difficulties handling the load of the video streaming. So we recommend that for all of you. Please use the chat. Sorry, every time somebody joins in, it blocks my screen. But we will use the chat function for all questions. If you have questions, please type them in the chat. If somebody asks a question and that question is also important for you, please use the like button to indicate that this is a question that you would like to see answered by the panel. The panel will take that into account and give it priority during the question and answer period. If you have any technical issues are typically related to your own IT, so please don't hesitate to contact them. And as I've already mentioned, this event will be recorded, so please be aware. So we'll move on to the next slide. Just a quick update for you to know that we will have moderators in the chat throughout the duration of today's call. You can see all the moderators on the screen. So if you pose questions and you see one of Chris, Adriana, Thomas, Cheryl responding, note that they're working for PINFA. We will continue. So yeah, you've joined this PINFA webinar. For some of you, who is PINFA? We're the Phosphorus and Organic Nitrogen Flame Retardants Association. We have approximately 28 members who are either manufacturers or major users of our three technologies that I just highlighted. We've been in existence since 2009. We're part of CEFIC. We're a sector group within the broader CEFIC organization. And we also have two sister associations, PINFA North America and PINFA China. So next you can see examples of our members. So here are some of our members. So you can see, as mentioned, we have big chemical companies, small chemical companies, producers, downstream users. And yeah, these slides will be shared after. So if you're interested in any of our members, you can go directly to their website and learn more about what they do and what they have to offer. We will continue. So yeah, here you have your local PINFA contacts. Should you need anything, you can contact any one of us on this slide. And yeah, we continue. And here are social channels. A lot of you follow us on LinkedIn. We also have a Twitter account, and our website is our primary information hub. So you should always refer to our website. Okay, so now we get to the exciting part of today's event and the reason why you are all here. So our first keynote will be given by Sylvie Lemoine. She's Suffolk Executive Director for Product Stewardship. Sylvie has extensive experience in EU affairs, and she's been in this field for over decades. And today she will be presenting to you what does safe and sustainable by design mean in the Green Deal for products, materials, and chemicals. So Sylvie, I will pass the floor to you, and please take over.
Yeah, thank you, Esther. Good afternoon, everyone. Can you hear me well? Because I'm not using the headset. Okay, wonderful.
Perfect.
Okay. Good. And now can you see my screen?
Yes.
Trying to put it in. Okay. Good. So thanks for the invitation. Indeed, we're going to spend 10 minutes to give you a little bit of a snapshot on what is the European Green Deal, and more specifically, the chemical strategy for sustainability, which is the really the heart of the transition to safe and sustainable chemicals for the future. First, it's important to remember that the European Green Deal is a flagship initiative of the current European Commission, and it touches probably every sector of every economic sector in Europe, from renewable energy, obviously, because we're going to move to electric vehicles, for example, but also it's about circular economy, it's about public health, it's about all the goods and products we use every day as consumers. And what's the commonality of all these sectors? They rely on chemicals. 96% of goods manufactured in Europe rely on chemicals at some stage. With chemicals, we also mean, of course, all the materials, advanced materials, etc. Pharma, whatever it is. And CEFIC, so that's why we call ourselves the industry of industries. And CEFIC is the European Association for the European chemical industry. We have 600 members, and we represent 550 billion euro sales of chemicals for EU 27. And when I say, we serve all the different sectors of the economy, this is just an example to illustrate how 3 different categories of chemistries serve, for example, renewable energy. Now, of course, it's many more than that. But it's whether it's the components, whether it's a solvent to manufacture a process, whether it's complex materials, it all comes together to make a product. And those products will have to be manufactured with less energy in the future and with recyclability taken into account. So what's the Green Deal? This is a slide from the European Commission, and it's the summary of all the main pillars of measures under the Green Deal. It's huge, it's extremely ambitious, and as I said, it's really the branding, what this European Commission wants to leave to the future generations. And this Commission has 4 years to plant all the seeds to make it happen. In the circles, you see what are the most important drivers for the chemical industry to transform. And I think if you look at that, what it signals is a need to really transition. And this transition is complex because we have high investment, very long investment cycles. And those challenges are multiple and they're real. So the 3 I highlighted is climate neutrality. We need to become climate neutral by 2050. We're in a sector that relies a lot on energy, but this energy has to become renewable, and it has to remain affordable, and it has to be available in large quantities. We need to improve on circular economy. We need to make our materials and goods recyclable. It's also part of, under circular economy, it's also renewable sources. It's also the ability to depend less on, for example, supplies from other regions for critical raw materials. So it's pretty strategic as well, it's long term. And finally, and importantly, what is called the zero pollution ambition. And it's under this zero pollution ambition that you find the chemical strategy for sustainability. So it's part of the Green Deal, it's part of the zero pollution, and the chemical strategy, although we already have the most advanced and most comprehensive legislation in the world with REACH and other legislation, the chemical strategy aims to really take it a step further. It's a new REACH, it's really a new chemicals legislation system we're going to see coming in the next 2 or 3 years. Trying to move on, sorry. So behind the Green Deal, there are behind the chemical strategy, more specifically, there are societal drivers. The Commission has run a number of studies and found that in spite of having all this legislation already in place, if you talk to people, 90% of Europeans are still worried about the impact of chemicals on the environment and on their health. So this gives a mandate to the politicians to act and to go beyond what is already done today. The Commission is supported by the other institutions, so very strong political support for this level of ambition and for the measures that go with it. It's supported by the European Parliament and by the Council, so the Member States. If you look at the broad vision of the Commission, we certainly fully agree. The vision is that chemicals are produced and used in a way that maximizes their benefits to society, while, of course, avoiding harm to people and the planet, and that progressively we shift to safe and sustainable chemicals, and that Europe would like to set a benchmark, so set the tone and then become a benchmark worldwide, and that's the competitiveness and innovation element of the chemical strategy for sustainability. So on paper, we certainly agree with this vision. We may not always agree on the details and how to get there, but certainly on the goals. So what does it mean in practice? The chemical strategy is actually a set of close to 60 major actions to be launched in the next 2 or 3 years before 2024. And most of them are legislative changes, including a revision of REACH. And all these actions go in the same direction, to have faster regulatory action, but also be more preventive and trigger a substitution of the most harmful chemicals. It's really major, it's highly ambitious. The measures will focus on hazard properties of chemicals more than today, because there is a perception that risk assessment is long and complex, and we need to be quicker, because as long as you don't take action, there's potentially someone or some species, or if it's in the environment, exposed to those chemicals. So really, the vision is this reverse triangle where the bulk of chemicals are safe and sustainable in the future, and certainly the new chemicals. Some chemicals have to remain because they're useful in certain applications, but then we will need to minimize and control their use in case there's exposure. And some chemicals will need to be eliminated or remediated. So as I said, we're going to see a move to more generic restrictions. So for example, based on certain intrinsic properties, without even looking at the specifics of the substance or at the exposure, if you have, for example, a respiratory sensitizer, it would automatically be banned into, for example, consumer products, because there is a generic exposure that has been deemed to be problematic, and therefore the intent is to prevent any exposure and restrict or ban by design from the beginning of the chain. So it will redefine chemicals policy. In addition, the strategy also introduces new concepts like essential uses. So some chemicals would be banned generically unless they are deemed to be essential for a particular use. Now, who's going to decide what is essential for society? That remains to be seen. And this is where the details will matter. How this concept of essentiality is used in practice. The strategy says it will phase out the most harmful chemicals for non-essential societal use, in particular in consumer products. Of course, in the area of fire safety, the use as such, protection from fire is obviously essential, and it brings societal benefits. The question is going to be which classes of chemicals are essential for use in this essential use. So the question is really, is the use as fire safety essential, or is it a given chemical Or is it the performance provided by certain chemicals that matters in the essentiality assessment? And that remains to be seen. Second, of course, we are moving to a more generic approach. So it will be increasingly based on hazardous properties. In some cases, it makes sense. In other cases, there is the potential of judging chemicals based on intrinsic properties assessed in a lab instead of looking at the real exposure and uses of chemicals. So here again, the details of implementation will matter. But the intent is the same, is actually to be faster and more effective and more ambitious in regulating chemicals, particularly for consumer and professional uses. Now let's look at what safe and sustainable by design is about. Well, we don't know yet. I mean, the short answer to the question, what does safe and sustainable by design mean for your sector, for flame retardancy? We don't all have the answers, but what we do know under the chemical strategy, the European Commission has given itself 2 years to come up with standard criteria. And with that we agree, because sustainability assessment is already in practice today, but different companies or different organizations have different methodologies for assessing sustainability. It's complex, it's multidimensional. And we need to standardize this so that it doesn't become, my safety or my sustainability versus your sustainability. So in principle, we agree with harmonizing the criteria for both safe and sustainable. Now, safety is primarily dictated by REACH and other legislation. And here again, the legislation will evolve. Safety is the starting point. Safety is a must, and there's no compromise on safety. But what will happen in the future is that once you have established safety, and there will be a need to generate even more data than we have today. Environmental data, data to check for potential endocrine disrupting properties, for example. And then we will need to add other sustainability dimension, particularly carbon footprint and recyclability is going to be increasingly important. What will be the criteria? Will we have all the data needed on the chemicals to do the job? That's the work that is going to that has started, and that will go on in the next 1.5 years. So this is our view, CEFIC's views on what safe and sustainable by design would mean. We see it as a process to bring to the market products and processes, because it's also about how we produce the substances. Make sure they are safe. They also bring, of course, societal value, because chemicals are there to provide a certain performance in a use. And it's really through the life cycle, through the application of chemicals, in order to accelerate the transition to a Green Deal world by 2030 and later on, and obviously preventing harm to human health and the environment. So the details will be complex, but the path is there. And I would really invite you to keep an eye on the developments, because it will be standardized and some information will have to be generated. And for it to just, this is the last slide, just to prove the point, the European Commission has already produced this mapping study, which is the starting point for starting to design criteria for safe and sustainability, safety and sustainability assessment. We're fully engaged, and it really aims, the path is there to really change the paradigm and move the whole chemical industry to a safer and more sustainable product. So keep an eye, because it will all shape up in the next 2 or 3 years, together with more regulatory pressure. Thank you.
Thank you very much, Sylvie, for an excellent presentation. You've most certainly opened the eyes and ears of everyone. And if you have questions for Sylvie, please drop them in the chat. She will be able to respond to you during the Q&A with the panel discussion that's to follow. Next, we have Margaret McNamee. She's a professor of fire safety engineering at Lund University in Sweden, and she is here to give us our second keynote presentation. Margaret, if you can already start your presentation, that would be great. And everyone, get ready to hear about fire safety challenges of tomorrow's materials, and Margaret will dive into the environmental aspects. Thank you, Margaret. The floor is yours.
Thank you, Esther. And thank you for giving me the opportunity to speak today at this important event about these important topics. And as you said, I'm going to be speaking about or around the topic of fire safety challenges of tomorrow's materials as an essential societal challenge. Now, I'm a professor of fire safety engineering at Lund University, but for much of my career, which spans over 3 decades, basically, I've been looking at the interaction between fire safety and sustainability. And that's partly where I'll be talking about today as well. But let me start by painting a picture of the fire problem. According to the World Health Organization, somewhere between 200,000 and 300,000 people die every year due to fires. And the vast majority of these are in low and middle income countries. And there are specific challenges in these settings that I won't be talking about today. But in a European context, somewhere around about 3,500 people die in fires annually, and at least 70,000 people are significantly injured by fires. In developed countries, we typically say that around about 1 to 2% of the gross domestic product is spent on fires and recovering from fires. And insurance statistics indicate that fires and explosions in the built environment account for around about 60% of annual business interruptions globally. So clearly this is not a sustainable situation. A couple of years ago, I had the honor to lead some work that was conducted by the International Association of Fire Safety Science. And that is an association that is an international charity, the leading international charity supporting research and scientific exchange in the field of fire science and engineering. And the study was concerning basic societal challenges where fire research has a major role to play. And you can see we came to a consensus about 2 very broad societal challenges that fire safety research can help us to address. And these were population growth, urbanization and globalization, and climate change, resiliency and sustainability. Now, it's the second of these 2 broad societal challenges that I'll be mostly focusing on today, where sustainable fire safety is a key aspect towards being able to attain or to deal with the societal challenge, climate change, resiliency and sustainability. And in particular, this has a relationship to new materials and technologies and what the fire safety and sustainability questions associated with them may or may not be. Now, in order to understand these global grand challenges, I think it's important for us to actually take a step back and look at what are the environmental impacts of fires, because this will help us to give a more detailed view of, or a more detailed understanding of what these global grand challenges require in terms of efforts made to address them. I should also say that the publication that we produced in 2019 is open access, and I've provided the reference here as well. I would encourage you to read it. There is some interesting material that's been put forward by 24 scientists that are from all over the globe, giving their ideas about what we need to do in order to be able to create a fire-safe world. So if we focus on the environmental impact of fires, then when we talk about the environmental impact of fires, we often think of rather a fire that's raging as we speak, and there are large volumes of black smoke being emitted from the fire and impacting on the environment. And this is one of the aspects of the environmental impact of fires. This is what we would typically call the local impact of fires. But there's also a global impact that we need to take into consideration, and that takes into account the whole of the life cycle of whatever it is that's burning. And so we need to incorporate life cycle thinking in order to gain an understanding of what the global environmental impact of fires are. Now, this approach can be particularly interesting for new materials, given the fact that we're not always fully familiar with what the life cycle impacts of those new materials may be. So the global impact is illustrated by this figure here that you see on the slide, where you're looking in terms of a circular life cycle where we've got raw material extraction, production, use, and various end-of-life strategies that hopefully lead into raw material extraction and so on in this circular way of thinking. Now, generally, this way of thinking does not incorporate an accident within the life cycle of the product or material. But in fact, if you do have a fire in your product, that shortens the effective or the efficient life cycle of your product, and you will need to replace it in order to be able to realize the full life cycle. So a fire would actually come into the use part of this circular life cycle thinking. And also the response to that. I mean, how is the fire brigade going to be reacting to the fire? Are they coming in and extinguishing the fire? Are they interacting with it in some ways? Because this is also going to impact on the overall global environmental impact of fires. And it also has an effect on the end-of-life strategies in terms of the fact that you'll have runoff water to take care of, you may have contaminated soil, and there will also be a need to replace or renovate the material that's been included in the fire. So complex questions, but in order to be able to understand the full environmental impact, we need to be considering both the local and the global. So I've spoken a little bit about the global. If we talk again about the local impact of fires on the environment, then we can think in terms of this fire impact triangle, where it's not just the fire itself that is important for us to be able to understand this, but also the response and how that can impact on the emissions, and the recipient. Where are the emissions going to? If we're having runoff water, is that being emitted to a hard asphalt surface? Is there a possibility for us to be able to collect that material? Or is it going out into the environment itself, into nature, and maybe with the risk of contaminating a water reservoir or something like that? This will impact on what kind of environmental impact you have. So if we break it first down into fire and response, the fire itself will be producing emissions in terms of the fire plume, but also in terms of the emissions that can go to soil and water. And how you're responding to the fire will change those emissions in terms of maybe you're cooling the fire, which will produce more products of incomplete combustion, and thousands of different species can be produced depending on the fire and the response itself. And which species are produced will depend on the fuel that's burning, but also on the ventilation conditions. If you have good ventilation conditions, then you will get more complete combustion, less of the environmentally toxic species coming from fires. If you have poor ventilation, then you will also have poor combustion and more of the species of incomplete combustion being produced. As an example, I could say that in a typical year, fires might produce around about a ton of particulate matter in Sweden alone. Now, keep in mind that Sweden is a fairly small country in Europe, a very small country in the world, and that this is a typical year. So it doesn't take into account the fact that if you have a year with large amounts of wildland fires, for example, then the emissions that you're looking at from fires could be significantly increased. In terms of recipient, I mentioned that your fire emissions could be coming to the air, to the soil, and to water. So from an environmental point of view, then thinking about sustainability, we need to be including things like the environmental impact of fires, and we need to understand that in order to be able to improve the sustainability of products. Given that I've only got a very short amount of time here to open some of the ideas that are included in this very complex topic, I'd like to just quickly summarize what it is that I'm hoping you will take away with you from this presentation. So fire safety research can help us to understand and realize some of the global grand challenges that we could identify. The International Association of Fire Safety Science identified 2 major global grand challenges, but the global grand challenges can be expressed in many different ways. in order to be able to try and address the broad grand challenge of climate change, resilience, and sustainability, it's important for us to start by having an understanding of the environmental impact of fires. When we're talking about the environmental impact of fires, it's important for us not just to get stuck on a traditional life cycle assessment approach, but to recognize the fact that fires have both local and global environmental impacts. For local fire impact, it's good if we can think in terms of the impact triangle, where we've got fire, response, and recipient all contributing to the local environmental impact of fires. In terms of global environmental impact, then we need to use a life cycle assessment approach. And in fact, it can turn out that replacement of burnt material and products is a very significant part, typically, of the global environmental impact. And finally, I'd like to say that it's important for us in understanding the fires and the context of fires that we think in terms of what we call the full emergency management cycle. And you can see a picture of the emergency management cycle on this slide. And this picture is also in that paper that I referred to at the opening. Here we need to consider pre-incident prevention and protection, the incident response, and also post-incident in terms of mitigation and recovery in order to fully understand what the environmental impact of fires are and how we can hope to create sustainable fire safety. After these short 10 minutes of presentation, I hope that you can agree with me in the fact that the best, most environmentally friendly fire is the fire that actually never occurs. Thank you.
Thank you very much, Margaret. Yes, I believe it'll be really tough for anyone to not agree with you. Yeah, and thank you to both of our keynote speakers for your insightful and mind-provoking presentations. Most certainly, people are going to have some, very valid questions to ask, and also post event thoughts to think about and maybe come back to PINFA. So thank you both very much. So next, we move to the second segment of today's event, and I would like to introduce you to your moderator, Adrian Beard. He's the chairman of PINFA, and he's also one of our very own senior experts in fire safety and environmental property, so phosphorus-based flame retardants. And yeah, he will be taking you through the second half of today's meeting. I will be still available through the chat moderation. So thank you all very much. And Adrian, without much ado, please take over.
Yes, thanks very much, Esther, for the kind introduction, and welcome to our panel discussion. So Cheryl, if you keep presenting the slides, because we have, an intro slide for each of the panelists, which I will call upon. And some of the panelists also have a slide prepared, so that's in the flow of this introduction. So I will present or introduce the panelists and ask each of them to give their short 1-2 minute intro statement, and then after that we take it from there. I'd also like to invite panelists to turn on their camera, so we also have the visual impression. So I'm delighted to walk you through this. So we want to continue what Sylvie and Margaret started, this discussion on the impact of the chemical strategy for sustainability for flame retardants, and then Margaret then highlighting the environmental impact that fires themselves have, and then that needs to be somehow taken into account in developing future-proof flame retardants and also materials in general. So without further ado, let's move to the first panelist. He is Laurent Tribut from Schneider Electric. He has a PhD in applied sciences from the National Institute of Lyon. So he's French. He worked for Nexans, then moved on to Schneider in 2013, and is very experienced in polymers for wire and cables or other electrical applications. And by now, he's also a member of IEC standardization working groups, and he has been on the advisory board for PINFA. So with that, over to you, Laurent, and I believe you have prepared a slide with an opening statement.
Yes, thank you very much, Adrian, for the nice introduction. So today I just wanted to show you the evolution of Schneider Electric product for better sustainability in combination with reliable fire performance and how we will address this through three main aspects. So first, the eco-design, and we will try to use flame retardant only when it is strictly necessary. We will also work on the prevalence of material with fire performance in bulk compared to a multi-layer system, because generally it's easier to recycle a single material than material with different coating. We will also probably work a little bit more with single flame retardant and prefer this to synergists in order to simplify the marking, the traceability, and later the recycling. Then we work on the safer flame retardant, so safety aspect. The idea will be to minimize first the halogenated flame retardant, because we know that it has had additional risk for regulation also during the incineration and at the end of life. And we will try to work on the selection of greener flame retardant, but it's not so easy because for the moment there is no official definition of what is a green flame retardant and how we want to assess and rank this flame retardant, and also what are the CO2 impact during the production phase, but also during the recycling phase. We will probably need to have some harmonization of the regulated flame retardant substances list worldwide, and also better definition of the testing methods to make the assessment of the presence of this flame retardant. And the third aspect is the end of life. As you know, the mechanical recycling is the preferred option many times because it's less impacting in terms of CO2, but we know that it is very difficult for flame retardant grade also to make a good sorting, and we will have to work on the improvement of sorting. Regarding chemical recycling, we consider that it could be good to work on the recovering of flame retardant, because for the moment it is seen as waste during dissolution process or pyrolysis process, but maybe it could be good in order to reduce the raw material mining to try to recover this flame retardant. And finally, we will work on the stability of performance after the use phase, because for many products, we want to extend the lifetime of our product, but can we ensure that the fire performance will remain the same after 20 or 30 years? It is a hard question to answer. Thank you for giving me the opportunity to be panelist for this event.
Thanks a lot, Laurent. Yes, and I think you highlight very well the say conflicts that occur when designing a material for optimum performance, but also taking all these environmental factors into account. But we'll come to that later. But thanks very much for this opening statement. So coming to Michel Cassard, he's with Plastics Europe. He's an engineer in material sciences, but also has a master in business administration, also had business management roles in the past. In 2016, he joined Plastics Europe, and by now is Sustainable Use Director at Plastics Europe, and coordinates activities related to sustainable use of plastics and safety of plastics and microplastics. So with that, over to you, Michel, and I think you also have a slide to show, right?
Yeah,
Michel.
just once. And thank you very much for these very kind introductions and for the opportunity to speak today and to be part of the panel. So as you certainly know, plastics is a key material, is a key enabler of our modern society. But plastics today is facing huge challenge and huge pressure, mostly due to the waste issue, to the handling of to the issue related to marine litters, microplastics, but as well all the time at the centers of all those discussions, the issues of the possible issue of the safety of additive used in our products. So what we expect to the additive, to the flame retardance additive for the futures is really that they support what are the main pillars, strategic pillars of the developments of the looking forward of the plastics, which is really making these transitions to renewable resources and a low carbon circular economy that we all need. So that's really a key element that we expect from the additive suppliers, because additives are part of the plastics. So to help us as well in accelerate the safe and sustainable use of plastics. So to support the safe use of plastics and the sustainable by extending the life cycle, ensuring that plastics are very durable, can be used safely in all along the value chains, all along the life cycles, from the productions up to the end of the end of life, ensuring the absence of exposure to toxic substance, since this is something that we need to continue be better and improve our transparency certainly to the entire value chains and to the outside worlds on that. And then we expect as well that from the additive that they help us and facilitate the transitions to the circular economy, and that they will not impact any type of processing that can conduct to the recycling of plastics, whether it is mechanical recycling or chemical recycling or any other elements, and that they contribute as well to the use of carbons in this circular economy.
Okay. Thanks very much, Michel. I think that was a very ambitious wish list you presented there. I think you realize that it is ambitious, but without ambitions, there's no progress. Yeah, and also highlights again the conflicts that may occur. Yeah, but
and that's exactly what the Green Deals and all the chemical strategy for sustainability is asking as well to the plastics industry and the strategy for plastics. That's what we are asked for the time being, and we need to find all the best way to answer to those requirements.
Indeed. Yes, thanks very much. Yes, now we coming from, say, the top of the supply chain, the OEM, Schneider Electric, producing electric insulation material products, final products, Plastics Europe representing, say, the polymer producers, compounders. Now we come to the environmental side. We'll come back to other parts of the value chain in a second. We come to the environmental side with a dear friend, Jacob de Boer. Welcome. He's a professor for environmental chemistry and toxicology at the Vrije Universiteit van Amsterdam. I hope I said that correctly, Jacob. And he's been in the scientific arena world for, I think, more than 45 years, dealing with contaminants in the environment. I think you were also a friend of my professor at university, Otto Hutzinger, many years ago. So there's a link also to the University of Amsterdam. And he's been working also on flame retardants in the past, brominated organophosphorus flame retardants, also polychlorinated biphenyls. He's written and published many papers, is on editorial committees, also published books like Handbook on Environmental Chemistry and so forth. So well-respected, well-renowned environmental scientists, and we're glad to have you here. Jacob, and isn't this all music in your ears, what Sylvie described in the beginning?
Yeah,
or what's your take on this?
Yeah, thank you for a very nice and kind introduction. I must say, answering your last question, is that as an environmental scientist, this new chemical strategy is indeed there is more music than there was in the 1980s or 1990s. That is true. So we are sort of, I'm optimistic anyway as a person, but I'm a bit more optimistic in this field now for the environment, maybe, although there are many challenges. However, I, in contrast with the previous speaker, although there was an interesting wish list, my wish list is very simple. That's not only because I have 3 minutes, but my wish list is no halogens. No halogens. And of course, flame retardants and other compounds can cause all sorts of other effects. We have the endocrine disruption problem. We have all sorts of different endpoints in toxicology. But I have seen, indeed, during many years, so many problems with halogenated compounds, and many of them were flame retardants, that I think that we will gain a lot if we could stop with that. And that sounds maybe sort of, very strict maybe in the approach. But I mean, I've gone through the PCBs through a series of brominated flame retardants. And if you see how much work we put into that, also in research, why we have banned 3 brominated flame retardants, and there are more than 70, if not more, around, then in fact that is sort of disappointing and didn't help us actually not very much. I'm fully involved in discussions on tolerance levels for PFAS. There's a big problem in Belgium, and there's new guidelines from EFSA, and there is an approach, at least a sort of a tentative approach, to phase them out as a whole group. I think that would be the only way. So that is my message, simple, and of course we can talk about all sort of other aspects, but again, I think we gain a lot when we could go into the future in a sustainable future, also in fire safety without halogens.
Thanks, Jakob. Good. We stay in the environmental arena, and I'd like to introduce it to you, Lauren Hein. She's an expert in green chemistry and engineering. She also has done a lot of work on alternatives assessment. She has developed green screen many years ago, and is now with a group that call themselves Chem Forward, and that have set up a platform for assessing chemicals and making those assessments, say, easily understandable, transparent for end users. I think that's the main benefit or selling point here. But I leave it to you, Lauren. How do you see this developing? Also, your perspective from outside of Europe. You live in the US. I forgot to mention that. You are from the US. You live there. But what's your take on today's topic? And you have a slide, I think. Yes,
yes, I do have a slide. Thank you very much.
There we go.
Thank you, Adrian, and thank you for the opportunity to be a part of this really interesting panel. I think we have well established that safe and sustainable is more than hazard. It's multi-attribute. As a colleague of mine, Mikhail Davis from Interface Carpet says, it's about chemistry, carbon, and circularity, in addition to social and economic impacts. And solutions will require both material transparency and chemical hazard transparency. And one goal of Chem Forward is to provide one that is consistent with safe and sustainable by design, is to provide one chemical hazard assessment per chemical in a centralized place where the information can be continually updated, shared, and accessed for lower cost than what's happening now with information tucked away in various consultancies. Chemical hazard information is needed for really all scenarios. I used to think of this as steps, but I think every company is working on these strategies simultaneously, working to eliminate highly toxic substances, usually driven by regulations or customer restricted substances list, to move away from the most problematic chemicals. Then moving a robust chemical hazard information is needed in an easy to understand format to select safer alternatives and to avoid regrettable substitutions. And then for safe and sustainable by design, information is needed on building blocks, chemicals as building blocks that are to be optimized across the full life cycle, considering feedstock, processing, and end of life material reutilization. Now, of course, the best solutions may not be chemical at all. at a minimum, safer chemicals must be used as a baseline, non-halogenated, inherently safer flame retardants. But what about chemicals that provide additional benefits? There are flame retardants that also do double duty as, say, plasticizers, or they help with reducing smoke in the case of a fire. Those are that causes collateral damage. One might select materials that are inherently flame retardant and require no additives at all in support of, say, the plastics vision, or focus on designing products that are unlikely to ignite by design, or even broader system interventions that reduce the likelihood of propagation if ignition does occur. I live in the Pacific Northwest of the US, where we have drought and fire is on everyone's mind right now. It's a terrible thing. And we are adapting our homes and our landscapes to be fire wise. That involves both where your trees are and what materials you use to protect your home. We need to invest in innovation across a spectrum of product designs, as the most sustainable solutions may not be available yet. What is especially tricky, as the point was raised, is how additives can promote or inhibit circularity depending on material life options. In the short term, I think it would be helpful to have a lot of demonstration products linking product stewardship and materials management to help refine these sustainable design principles. So we may be looking at a lot of closed loop experiments in the short term to really help understand how to align fire safety with sustainable design. So thank you.
Thanks a lot, Lauren. Thank you. With that, we come back to the top of the supply chain, so to speak. So meet Stefan Giensle, who's a former senior manager of engineering and materials at Daimler-Benz, the quite well-known German car manufacturer, not only cars, also lorries. He has a background in mechanical engineering. He's from the Stuttgart area in Germany, where also Daimler is located, our headquarters are located. And he's worked in different engineering and management roles. He was a senior manager, for instance, for engineering exterior, body, cabin, and materials. He's also a member of the advisory board of the Fraunhofer Society, the German government-run research society. Also lectures at the University of Karlsruhe, or Karlsruhe Institute of Technology, as it is called. So has a broad background in material sciences and engineering. And since 2019, he's an independent consultant on the topics of materials and engineering for automotive. So with that being said, over to you, Stefan, to your statement.
Yeah, thank you. It's a pleasure to join the webinar. As mentioned, I am not anymore at Mercedes. That's very simple. I was head of the research and advanced engineering side in Ulm, where we developed, for example, the latest EQS. That's now in the sales rooms, or the last S-Class. And having such a thing done, I thought it's some time to change, because that was more or less the peak for me as an engineer. I had a lot of experience with materials, with material choice. That was also one of my responsibilities in former times. So I was glad to be with you, and I got the first job to make a statement for 3 minutes. And sometimes it's good luck, because specifically there are 3 topics for automotive, the automotive perspective concerning fire. First is avoid, second is delay, and the third is then to manage. What does it mean? Of course, avoid means take the materials that have the best fire protection classes. There are a lot of things, tests done, that the material has to fulfill until it gets a clearance at least in the premium OEMs in Europe, where I really deeply know. But I think in the total, on the global car market, it's similar. The material, of course, then the way how the vehicle is designed. If it's in a crash situation, of course, it's very reasonable to have a crash protected area where all the liquids that could get in fire are protected. For example, where to place the tank. Second is delay. If it's clear that there will be a fire event, I don't know, hopefully you never experience such an event, but if you think about how long would it take until you have the first indication, either it's the smell in the interior of the car or you have any red signals in your dashboard, it takes about today 5 to 8 minutes until really the fire event is evident and you have to more or less to leave the car immediately. And that means delay. It should be not an explosive event, but it should be an event you can still react and more or less save your life. Mm-hmm. And the third is if then there is a hazardous event, to manage it. That means what is the behavior of the firefighters? That is a huge topic in the battery-driven electric vehicles and so on. So you can see if the avoidance, the delay and the management of a fire are optimized, are still supported with new materials from all the supply base, then we can say that today about 50,000 fire incidents or accidents, call it incidents or accidents in Germany with cars, that can be really covered, and it's, for heaven's sake, not a huge or not the biggest problem on our streets.
Mm-hmm. Okay, thanks very much, Stefan. So now we come to our final panelist, also PINFA member or coming from a PINFA member, Radici. We're glad to have you here, Joachim Stricker. So welcome. He has a background in plastic engineering and studied at the Technical University of Aachen here in Germany. Also worked for the automotive industry in that capacity. And in 2004, he joined Radici, where he worked as regional sales manager, also marketing and technical service manager, and now is focusing his activities on marketing for the E&E industry in the Radici Group High Performance Polymers. So with that, over to you, Joachim, and you have also prepared a slide, I believe.
Yes, thank you, Adrian, and thank you to all the audiences. Yeah, Radici Group, as you can see here from what we just show very briefly, let me say, the sustainable development is more or less, it is rooted in the DNA of our company and of our group. And since we are producers of polyamide, raw materials, as well as compounds, we started immediately with the start of our activities, our industrial activities, also to have a more than only slight look on environmental aspects of our activities, of all our processes. We started to use renewable energy from power station, from hydropower station, and this is continuing to the early 2000s, when we started the global reporting initiative, where we put our first step into the management or the documentation and communication of the environmental footprint we leave with the production of our materials. That leads for sure to the very next step, that besides the pure technical properties we submit to our customers, we also started to make a kind of, I like to call it, environmental data sheet, the environmental product declaration. And that starts, of course, for all our products which are sold to the market, with prime grades coming from direct polymerization and compounding, as well as for the recycled grades we offer to the market. And yeah, not to forget, that last but not least, that it gets more and more important for our application, our customers in the electronic and electric industry, where we are strongly requested either to give immediately at once a clear commitment to a sustainable and eco-designed material, also from the perspective of a granule producer, as well as we work, what we heard today about the European Green Deal in many public-funded projects to the reuse and the circular economy approach of using as much as possible recycling rates, and last but not least for our flame retardant products, for which we use all the flame retardant additivation systems on the market. So the step is done in the right direction for circular economy. Of course, it's a long way to go. And as we still hear, a lot of challenges are to be faced, and of course, not to forget the property and the performances of our materials that should definitely not be sacrificed only for sustainability approach. Thank you.
Thanks, Joachim. Thanks very much. Yes, so with that, we are past the opening statements and we can now enter the discussion. I would like to come back to Stefan and also Laurent and ask, from our point of view, as PINFA, as a group of producers of flame retardants, of course, our question to the others in the supply chain, further up in the supply chain, is what can we do to support development of safer products, and how can we support you? Do you feel that you get enough information in ingredients in your materials? Is that difficult to come by? Also, looking at also what Joachim explained, is what the chemical industry, also the polymer industry is doing. Is that enough? Is it a good first step? Or what's your take on this information on chemicals you use in your supply chains?
So let me take some thoughts. Of course, there are huge information, there is huge experience in the whole automotive supply chain, because all the members, or most of the members in PINFA you mentioned, are of course in the automotive supply chain. So there is the good situation that all the knowledge at the end is capable or is available. That is for the classical thing. But now imagine what we are now currently doing. Automotive is in a transformation. There is somebody calls it disruptive, others say it's a normal thing. But the new powertrain systems, either from hydrogen-based or from battery electric-driven based, these bring, of course, new situations concerning fire, because if there's a material, I think it's clear that there could be a fire. And therefore, now going in the battery, for example, the OEMs, of course, have to produce and to make the car as safe as possible. But if you go deeper in the cell, for example, then it's more or less the boundary condition or the borderline to the chemistry. And therefore, what are the materials that could be even in a cell be added to protect, for example, this thermal expansion or this sudden thermal events that could happen if there's an impact, if there's a short circuit. And therefore, it's important, what are the materials? Do you have spacer materials in your warehouse that could be embedded in a battery, in a cell, or wherever is the area? If yes, it must be as soon as possible on the table. And of course, it should not be then as expensive as one golden nugget. That's for sure. It should be available. Other things that's for automotive business relevant. But I think there is still a momentum, and there's still an opportunity combined with these new propulsion systems, as I mentioned. That would be no arrow to make their more deep dive and have their concentrated action or activity to support the automotive and also the tier 1 and the tier 2 business.
Yes, okay. Thanks, Stefan. And we have been addressing that as PINFA with dedicated webinars on e-mobility and materials used there. So we have been picking that up. But perhaps also coming to you, Laurent, on this point, say transparency along the value chain, and you also mentioned that, I think, on your slide.
I think we are some information are still missing, especially the ranking of green FR. We have green screen ranking, which is very good thing, but then we have to know if it's a tool which is agreed by other NGOs and globally recognized. I suppose that it's the case. And then in this case, we would like to have more substances which has been assessed by this tool, and also in the majority of the formulation we have synergists, and sometimes we are not aware of all the synergies which are used, and for some of them they can have a lower ranking than the others, and we still don't know if we have to ban these synergies completely. If we have to, and if there are some technological solution to go out for all the matrix and all the polymer we are using, and also one important point was during the presentation of Margaret regarding the fire effluent. It's not so easy to know what are the substances which are generated in case of fire by all these substances. So even if the substance, the flame retardant itself is not hazardous, we also have to check and assess what is the impact of the effluent. And for the majority of flame retardant, the information can be fine, but it's not so transparent and not so easy to, and especially because it's also depends on the venting.
So, the conditions, yes.
The condition and especially venting. So it's the information maybe which are missing.
Yes, thanks. Maybe at that point I can make a little sales pitch for PINFA. We did run a technical project looking at polymers, and Laurent, you were also involved, looking at different polymers, different flame retardants, and looking at smoke, amount of smoke and toxic components in smoke. So we did address that question, but of course it can't cover all and not all circumstances or all conditions. But just to mention that, and you find information on that on our website. Yeah, just to mention that. Good. Any thoughts, perhaps, Michelle, also on this point of say, how can we support as flame retardant industry our partners in the value chain? You as say representing the plastics or polymer compounders and companies.
Yeah, and I think from that standpoint, we as well as plastics producers needs to further improve about the transparency of the products we are using. There is a lot of developments done today, and in already since years in the case of the automotive industry, where you have this
IMDS,
list and exactly in place. But you know that one of the elements which is coming with the chemical strategy for sustainability is this digital product passports, and that we clearly support that. Of course, we have to protect up to a certain levels the confidential business informations, because the details of a compounding formulation is something which is very critical for a compound producers. But we need to ensure that all the safety important informations are going all along the value chains up to the end of the value chains, and that it's really there to protect the end users, and finding the right balance between to improve these communications while protecting the confidential business informations will be the key for the futures. But developments are coming, and maybe the good example it's the car industry, but there are others as well under developments, and I'm very pleased to hear the works currently done by Laurent in that direction.
Yes, I think this development towards a digital product passport in Europe, the challenge will not be IT, because IT systems can nowadays handle this data volume. I think it's as with all databases, the challenge is in the quality and maintaining the good data. That's the big challenge. And having when I think of thinking of cars, every car is unique in its say composition. Yeah, one has leather seats, the other has textile, and all the rest. Yeah, so So you need a digital passport for each individual car with thousands of components and all that. I think nowadays, IT-wise, manageable by the volume, but who can keep track of this, and how can we handle this, say, from the data maintenance and then making sure data is good and valid? Yeah. Have you, Lawrence? Sorry, Michel. Yeah.
No. And I said as well, what we have to avoid is overload of informations as well, because that's the danger as well of it. If we provide too much informations, then at the end you cannot find the relevant informations anymore. So the right balance needs to be found there as well.
Yes, I was going to ask you, Lauren, have you heard about digital product passport or considered attaching or linking your ChemForward database to that perhaps in future? It's still all under development, so you haven't missed a final product yet, but perhaps something to consider. Yeah.
Right. No, it's I just made a note to learn more about it. We've definitely in conversations with number of electronics manufacturers who feel that they want a centralized repository of this information where you have access to both hazard information on chemicals at the CAS or EC number, but also at the trade name level, so that proprietary formulations can be protected. And then we're actually looking at talking to various supply chain market tools to begin to integrate that information, just feed the data into supply chain tools, but it's not currently connected to the digital passport. It's more like market systems or communication with OEMs, so to help feed this information in. And also allow the information, the hazard information to be challenged, because, hazard information evolves, right? There could be changes to regulations, new data that come. So having things centralized allows for continual improvement and updates, and manufacturers to even bring data that may not be published. Things like that, so that we think that's important. But yeah, it has to integrate into the supply chain. And I think what's very true is that the toxicology is challenging, but really the business model is the most challenging part. What you described, how to integrate this into the supply chain. That's enough information, but not too much information. And then, for those few who want to do a deep dive, they can understand the credibility behind it. But most just need to know, can I use it, not use it? Is it a good one? Is it a less good one? Things like that. So it's challenging to get that right. And that's working hard on that. So.
Thanks, Lauren. Yes, we're already approaching the end of our allotted time. As usual, as you start chatting, discussing, time flies. Yeah, I hope also for our audience that you found this interesting. I just wanted to pick up, say one stream from the chat. Not surprisingly, Jakob's short wish list or statement created a bit of a stir there, which is understandable. And there was the question, what's the, say, scientific basis, or how can you further justify this? I don't think we have, say, the time to go in depth, but I just wanted to give you, Jakob, perhaps the opportunity to reply to that briefly. Yeah.
Thank you very much. Thank you very much for picking out this question. I was hoping for that. Yeah, there's of course a lot to say about that. And there are a couple of things, because it was said in the beginning, this new approach would be in the sustainable chemistry strategy would be more hazard-based than risk-based. Then for sure you have already one argument. I fully admit that there will be some compounds which are of course different than others if you look to this sort of larger groups of fluorinated or brominated and chlorinated compounds. But I have seen so often and so long discussions in the past where we apparently sort of refuse to learn from cases like we had with DDT, which has nothing to do with flame retardancy, but you know, we came into the PCBs, and all the time I was in discussions of are they really toxic or not? I heard people saying to me, you can eat them. It was not the case. They appear to be toxic. Then you came into the situation and arguments that there were no alternatives, then the alternatives were expensive, and then there were alternatives. What I see now, for instance, with PFAS is for many applications, maybe not for big oil fires at the moment, but for many applications we have alternative. And I see so much creativity, certainly with all these wonderful people around the table, that I think it is possible. I won't say 100%, but and maybe some compounds with a chlorine here and there could be acceptable. But give me a list of halogenated compounds which are supposed to be safe. Tell me, because I'm interested to see that. But I think it's very difficult to produce such a list. So of course there is, you know, this is very rich at what I said, but I think it's good to start from that and then see how far we can come, because it has created, you know, so many political problems, financial problems. Look at Belgium at the moment again. I mean, I think it's been enough, and now we have this opportunity to work along these lines. I think there are many good alternatives. Yeah.
Okay.
Yeah. Thank you.
Okay. Thanks, Jakob. Good. With that, I'd like to close the panel, but not yet the meeting. So sorry to have to cut the discussion short. I'd certainly love to continue, but we have to keep these, say, online webinars concise, crisp, and sharp for our audience. So thanks a lot for our panelists and also our keynote speakers in the beginning. We would like to take you back to, or have a look back to the Mentimeter exercise we did in the beginning, and we have 2 more questions for you before closing. So this is just a look at the result from earlier, which somehow I think also links to what Jakob was just saying. Will safe and sustainable by design change what kind of flame retardants we use? Yeah, and that may not only be related to halogenated or not. It can also, of course, refer to the spectrum of, say, non-halogenated flame retardants that could be used further. Yes, and a clear vote in favor. Yes, it will have an impact. Yeah, it will have an impact on portfolios, on companies' portfolios, on the use of chemicals, yeah, flame retardants. Good. With that, I don't know, Esther, you're in control, I see. Yeah. Shall we go to the next question here? Oops. Okay, didn't we have a feedback question, Esther?
Yeah,
there
it's
we go.
Mentimeter doing some funny stuff.
Sorry,
you have 10 seconds to respond, it seems. So please go ahead quickly.
Okay.
I don't know why.
Okay.
Okay, hold on. I will try to.
Reload.
It's still open. I'm gonna go off sharing, but maybe Adrian, in the meanwhile, I'll bring it back up again. But in the meanwhile, we can start also wrapping up and thanking.
Okay. Yes, and don't be confused by this. None of the options are correct. Of course, the very satisfied is certainly correct. I think it's the way the question was. It's in the Mentimeter. You can set up something like a quiz, yeah, and then there is a correct answer. So sorry for that slight mistake there. But of course, I'd like to thank all our speakers, the panelists, also you, the audience. Thanks for sticking around. I see in the beginning we had 110 roundabout. Now it's still almost 90, so very good turnout. Thank you all for participating. If you have further questions, please come back to us via email, on our website, LinkedIn, Twitter. Please stay in touch, and we will also have more events of this type, even though we hope we can go back to having physical meetings. I think these webinars are a thing that will stick around because they have the huge advantage of having a low entry barrier. You can participate from anywhere, just dedicate an hour of your time or an hour and a half and not having to travel to Brussels, even though I don't mind going to Brussels once in a while. This certainly is something that will stay, but we'll also have again face-to-face meetings in future, in addition, or hybrid ones even. Yeah. So thanks again, everyone. We are now even 3 minutes short. We weren't quite sure how long the wrapping up would need. So thank you all for participating. It was a pleasure to have you all, and then the good lively discussion, also controversial, but that's why we have discussions. Yeah, that there may be differences of opinion. And here at PINFA, we certainly want to learn. We want to learn listening to not only our customers and further down the value chain, end users of flame retardants, but also the environmental side, and learn, and also take these learnings back to our companies for developing even better flame retardants for the future. So thank you all. Esther, any final comments from your side? Other than that, we'd like the panelists,
Yeah,
if you can, please stick around just a few more minutes. But Esther, over to you.
Yeah, just again, from my side, a big thank you to everyone for joining us today. We will share the video recording of this event. We will also share the presentations. So be rest assured, if your colleague wasn't able to join and they're still interested, you will have access to that. As usual, if you like this type of content and you would like to stay connected to PINFA, you can connect with us through LinkedIn. That's our biggest channel, our website, and of course, if you're on Twitter and in the EU Affairs area, we're also on Twitter. And on behalf of the organizing committee, I would like to thank each and every one of you. Enjoy the rest of your day. And a really massive thank you to all our speakers and presenters today. Yeah, so we wish you all a great evening, afternoon, morning from across
Summer.
the globe, and a happy summer indeed, Adrian.
Okay.
Yep. Thank you.
Okay. Thank you very much.
Thank you.
Bye-bye.